from a 2-carbon compound to, or I'm sorry, 3-carbon compound to a 2-carbon containing compound. So I'll put it right here. I got 2 carbons there. But in order to feed it into the citric acid cycle, not only do I have to take a carbon off of it, I have to remove some hydrogens. So when you take hydrogens and electrons off of something, what's that called? Oxidation. So if I oxidize something, I got to reduce something, right? And what do I like to reduce?
Hydrogen? No.
NAD, to make NADH.
Oh, right.
Okay, you with me on that? So if you take a carbon, check this out. If you take a if we were good organic chemists, which I'm not, by the way, but if there are any good organic chemists in here, and you actually knew the structures of all this, you see it. It's brilliant. I mean, you can see it happening, right? I don't remember the structures, and I can't draw them for you, so I don't really care. So you just have to trust me when I tell you this, that if I take pyruvate, and I remove a carbon as CO2, and I oxidize it, I make something called acetate. Or acetic acid, right? Acetic acid has 2 carbons. You know acetic acid? Where do you find acetic acid if you want to find
Vinegar.
it? Vinegar, right? It's vinegar. So we have acetate. Now this acetate with 2 carbons, this is what I can now feed into the citric acid cycle. Now, this bringing in acetate into the citric acid cycle, that is a chemical reaction to get it in there, right? Are there enzymes associated with that? Absolutely. And in fact, here's a case where we have an enzyme called coenzyme A that we need also to help us bring it in there. So it's just because this reaction is an enzyme catalyzed reaction, I'm just giving you the fact that there is, in addition, a coenzyme that is necessary in this case, and that's called coenzyme A. So essentially what we get here in these reactions is I go from pyruvate to what we call acetyl-CoA. And it's this acetyl-CoA right here that can be brought in. How many carbons are there in acetyl-CoA? 2. Well, that's not true. There are more in the coenzyme A, but that doesn't count because it's an enzyme. It's not part of the reaction, right? So that gets fed in. You guys okay with that so far? So all we're doing is bringing the carbon. So these reactions right here, this book calls them transition reactions. I tend to call them preparatory reactions because they prepare pyruvate for the citric acid cycle. So these are the, you'll often hear me talking about these as the kind of preparatory reactions here. Okay? And then you have these carbons come into the citric acid cycle. And let's see if I can summarize what happens here. Oh, let's see. There are 3 places in here where there are oxidations, which mean we should have 3 places where we reduce NADH. Is that okay? Make sense there? Does that make sense? So if you see NADH coming off, all that should tell you at this point, since we don't have the chemistry, is that that's a redox reaction. Okay? You okay with that? And then there's one place where the oxidation of the substrate in here does not release enough energy to reduce NADH, or NAD, so we reduce FAD, and we'll put up here. So what do these things represent? These things represent electron carriers and redox reactions, right? And where are they going to carry electrons to? What's their point? Is to take the electrons from acetate that came in, right? And feed them into electron transport chain. And where's this happening? In the mitochondria. Now, 2 carbons come in, and there are 2 places here where we lose carbon there, and we lose carbon there. So we've accounted for the carbons, right? 2 carbons come in, 2 carbons come out. At this point, right here, we've accounted for all of the carbons, right? How many carbons came in? 6. 6. 1, 2, 3, 4, 5, 6. Because each one, everything down here, right, remember, is times 2. Does that make sense? Yeah, 6 carbons came in. In glycolysis, we still have all 6. We do the prep reactions. Where are the carbons now? 2 times 2 is 4 here, right? There's 2 of these and each one had 2 carbons. 2 times 1 is 2. There's the 6 carbons there. These go away. You exhale. This one, you still want the carbons, right? Because you still want the electrons that are in acetate. You feed that in here, do the citric acid cycle magic, right? And there are 2 places where you actually release CO2 here. So 2 times 2 is 4 carbons come in. 1 times 2 is 2. 1 times 2 is 2 there. 4 carbons come out. So at this point, of the 6 carbons that came in, where are they? CO2. And out of your body. Waste. Right? You cannot oxidize CO2 any further. There are no hydrogens. There are no source of electrons.